So what is the scientific method? The scientific method is really just a systematic, universal approach used by scientists to explain observations. So explain everything around us, the natural world and its phenomenons. It also ensures that conclusions are as error-free as possible. The scientific method consists of 3 steps. The first step is observations, the second step is a hypothesis, and the third step is an experiment. Now keep in mind, depending on the problem, the scientific method might change, but these 3 points will always be in every single scientific method procedure. So the first point is observations. What are observations? So observations are essentially what we see, what we experience, any data that we can take down. So for example, it could be that the sky is blue. That could be an observation. We see that the sky is blue. We could taste something as spicy. We could measure something and see that it weighs 10 grams. We could take a voltmeter and we can measure the voltage across a current across a battery and figure out to be 12 volts. Basically any data we can find at all is an observation. Now, there are 2 types of observations. You have quantitative and qualitative. Quantitative observations are ones that involve numbers. So, for example, this weight measurement and this voltmeter measurement, they would both be quantitative observations, okay? Another example would be a car traveling 3.4 meters per second. Those would be quantitative observations. Qualitative is anything that does not involve numbers. So the examples I had, the sky is blue. That's a color. That's not exactly a number. So we don't give it a quantitative observation. It's a qualitative observation. Or saying that water is liquid. When we observe that something is a liquid, that's not a quantitative observation because we are not dealing with any numbers. We're just stating the state of a certain substance. Okay? The second step is a hypothesis. And a hypothesis is essentially a possible explanation for an observation. So if we use the sky is blue example, we might explain why the sky is blue. A possible hypothesis, a possible explanation is that the sky is blue because there are Smurfs in the sky that are releasing, blue pixie dust, producing a blue color in our sky. Now, whether that's true or not, we don't know. It might be true, it might be false. We don't know yet. All we're doing is proposing a possible explanation for the observation. And in this case, the observation is that the sky is blue. Okay? Next is an experiment. The experiment is where we test the hypothesis, okay? So whereas in the hypothesis, we were trying to explain the observation, in experiment, we are trying to test the hypothesis to see if it is valid. We want to see that if it's a legitimate hypothesis and if it's accurate, if it's truthful, okay? With each new experiment we do, it will lead to new observations. So with new observations creates new hypotheses, and new hypotheses create new experiments. My bad. So let's take the sky is blue example, okay? So our observation was that the sky is blue, okay? That's something we observed. The hypothesis was that the sky is blue because of Smurfs in the sky producing pixie dust, blue pixie dust, okay? How do we test it? How do we do an experiment? Well, what we could do is we could go into the sky and collect a sample of all the molecules, all the compounds in the sky, and figure out if there is blue pixie dust inside that sample. If there is evidence to support that our hypothesis is valid. There's evidence to say, hey, there is blue pixie dust in the sky, and because there are blue pixie dust in the sky, there might be blue Smurfs in the sky producing that blue pixie dust. That is, if we came to that conclusion, we are essentially seeing if our hypothesis is valid using an experiment. Now, if that wasn't the case, if we didn't find anything, which I believe would most likely be the case, then our hypothesis would probably not be valid, and we wouldn't have enough evidence to support our hypothesis. Now, after a bunch of hypotheses, we can start to develop a theory. And a theory is essentially uh, several tested hypotheses that give an overall explanation of a natural phenomenon. Okay, a best way to explain this would be the theory of gravity. Okay, the theory of gravity explains why two objects with mass will feel an attractive force to each other. It tries to explain that. How is that different from a law? Well, a law is a natural phenomenon. So whereas a theory is trying to explain some natural phenomenon, a law is a natural phenomenon. It's an observation, not a hypothesis, but an observation that happens consistently across a broad range of situations. So the example I'm going to use is the law of gravity. The law of gravity states that two objects with mass will feel an attractive force with each other. Okay, that's the law of gravity. What's the theory of gravity? The theory of gravity tries to explain why that happens. This is the why. Okay, the theory of gravity is why do two objects with mass feel an attractive force with each other, whereas the law of gravity simply states that two masses will feel an attractive force with each other. So that's the difference between a theory and a law. A law is an observation, and a theory is an explanation.